All right. All right, let's get started. If you can't hear me or see the slides, let us know by using the questions widget. That's the only way to talk to us for this webinar. So people are still joining in, but we're going to get started. Thank you all for joining the webinar today. In the room, we have me, Justin Mancinelli, and also Kevin Galligan and Sam Hill, who have been knee-deep in the technical side of things for quite some time. We're TouchLab, a mobile innovation consultancy based in New York City with expertise in Kotlin Multiplatform. We also do mobile engineering audits, change management, training for multi-platform development, and app building for iOS, Android, and multi-platform. We are here today to discuss how to think about cross-platform solutions and the trend towards native multi-platform solutions. This is for developers, engineering managers interested in understanding the current state of multi-platform solutions, including some familiar faces like Xamarin and React Native, and also some new entrants like Flutter and, of course, Kotlin Multiplatform. We're going to demonstrate that the future of these multi-platform frameworks is native. And we'll also answer some questions from the audience. We don't have time for all the questions as we're oversubscribed for this webinar, but we will include contact information for offline discussions, and we'll be sending follow-up documentation. I am going to go through the history of multi-platform solutions, present 3 models for thinking about them, and tell you a bit more about TouchLab's journey through this space as we go along. Before I dive in, some housekeeping rules. You can submit questions anonymously if you'd like via Zoom. Our moderator on this side will pick up some questions, and either myself, Sam, or Kevin will answer the questions at the end. All right, first, a bit about me so you can understand my interest in this stuff. I have been at TouchLab for over 3 years. Before joining TouchLab, I spent 8 years working and studying in Taiwan, Australia, and Japan. I got to learn how different teams and cultures work together. I also worked as a backend developer, team lead, and project manager, sometimes concurrently. At TouchLab, I work with clients of varying org structures, processes, disciplines, competence, size, and types of products. Day to day, I think about the client's products. I think about their teams and TouchLab's teams interacting with them. I also think about the business needs of our clients, releasing on budget and on time, ensuring when the project is done, our client is left in the best position for their future needs. A client's readiness for multi-platform solutions and the appropriateness of the solutions, given their context, is key to a successful multi-platform project strategy. We at TouchLab believe that Kotlin Multiplatform is the technology stack of the future. We are contributing to the core framework and libraries, and we are consulting with clients on how to be productive with it right now. Cross-platform is an overloaded term and now has negative connotations. Not all of you may believe this, but some of you hear cross-platform solutions and think it's slow. I'm locked into the vendor who's providing the solution. It's going to have a poor user experience and even more stuff. Some of you are subscribers to our newsletter or otherwise follow what we write, and you may have seen our article, Cross-Platform. We don't say that around here anymore. It's the baggage associated with cross-platform solutions that leads us to prefer the term multi-platform. Portable, platform-independent, cross-platform, and multi-platform are all terms that have been used for a long time. They have been used sometimes interchangeably, sometimes distinctly, and often confusingly. The idea of the future of cross-platform as native came from looking at the history of multi-platform solutions. Let's take a look at the trend. Shared code is the history of computing. Early on, platforms were defined by the hardware architecture and multi-platform tools were determined by the assembly language available. I call this the CPU as a platform era. Algol 68C was the first language that could be compiled on one machine for multiple CPU architectures. That is, and this is an important term, it had support for cross-compilation. Intel built a CPU architected with Algol family languages in mind, like C, which you all have heard of. And IBM chose Intel for the first PC. Another important term is transcompiler. That's a tool that automatically translates from one high-level language to another. XLT86 was the first transcompiler. It took assembly language, which doesn't sound high-level now, but was back then, from earlier Intel CPUs and could output assembly for the newer CPUs. So you didn't need to rewrite your app for multiple platforms by hand. Since these compile or transcompile to a representation native to each platform, they are native multi-platform solutions. And I've colored these green. In the 80s, cheap personal computers and servers began converging on Mac, Windows, and Unix operating systems. The platforms became the operating systems, and multi-platform tools needed to cater to different UIs and APIs. I call this the operating system as a platform era. There have been many multi-platform developments for this era, but I'll be ignoring them for the rest of this presentation to focus on web and mobile. Having said that, C and C++ were, and still are, heavily in use to share code across operating systems. Moving on to web. In the 90s, we enter the web as a platform era. The web has always promised to be the platform-independent platform, but the browsers have always had their quirks, and there have been so many of them. Java and Flash entered the multi-platform space as solutions to the cross-browser compatibility problem. But they've had their own problems too, which is why Java applets and Flash plugins aren't acceptable anymore. These aren't purely web solutions, and they aren't purely native solutions either, so I've colored them blue. With the introduction of the iPhone, we enter the mobile as a platform era. When announcing the iPhone, Steve Jobs used the term baby internet for what mobile devices could support before the iPhone, and desktop class applications for what they could support with the iPhone. Adobe and the Web Standards Committees knew they needed to bring a better web to mobile. Adobe pushed forward with Air, and later PhoneGap built on Cordova. Responsive web became a standard with the introduction of CSS3 media queries. Responsive web and Cordova work well together as hybrid solutions. But hybrid solutions treat web as first class and mobile as second class. I've colored them red. It's worth noting that when V8 was released with Chrome, JavaScript and the web became more native, and Node.js took advantage of that to bring performant JavaScript to the server. It's also worth noting that Appcelerator bridged JavaScript and native mobile 6 years before React Native. Both Node.js and Appcelerator took inspiration from web solutions, but understood that the web shouldn't be the primary platform when you're building for the server or mobile. Lastly, we get to the more forward-thinking tools of the modern era, where we see them trending back towards native-oriented solutions. And this, rightfully, is where they should be trending. Next, I'll look at some of the more popular tools from 3 perspectives. A model that gives more insight into what native really means, a model that helps us understand the difference between web, hybrid, and native apps, and a model that unifies the developer experience, the user experience, and the implementation details of different solutions. When Google announced official Kotlin support at I/O in May 2017, TouchLab was deep in the middle of Google's J2 OBJ-C of turning Google's J2OBJC into a first-class Android and iOS code-sharing toolkit that we call Doppel. By building mobile-first libraries, improved Gradle support, and even the ability to interactively debug the original Java code from within Xcode, we were transforming production-proven multi-platform tech used in Google's apps, such as Gmail and Hangouts, into a comprehensive mobile-first multi-platform solution. Unfortunately, with the Kotlin announcement at I/O, there was a very sudden change in tide where Kotlin became cool and no one cared about Java anymore. To make matters worse, we also saw that Swift was gaining popularity at an accelerating rate. So, building a product with both feet firmly in Java and Objective-C camps clearly wasn't going to end well. That's when we started looking for alternatives while continuing to improve and support Doppel, just in case. Later in 2017, I had this crazy idea that maybe there were research papers published analyzing the multi-platform solution space. Instead of marketing material that compares React Native to Xamarin or amateur blog posts that confused the differences between native apps and cross-platform apps. I found a few papers that provided a lot of good context and organization to the ideas floating around in our heads. Okay, maybe more than a few. I took these different perspectives and I simplified them into this diagram. Here's where we find out what native really means. And even simplified, there's a lot going on here. This input category that you see on the left is how the app developer writes the app. A native language is a language officially supported by the platform. That is Swift and Objective-C on iOS, Kotlin and Java on Android, HTML, CSS, JavaScript on the web. An other language is a language like JavaScript on mobile or ClojureScript on the web. Other languages also include WYSIWYG visual programming interfaces that some no-code multi-platform solutions use. The process category is what the build chain does to the input in order to create an output. I mentioned cross-compilation and trans-compilation earlier, but to clarify both of these, cross-compilation here is when a high-level language is compiled directly to the native code for various platforms before outputting the final product for each platform. This is called ahead-of-time compilation. Trans-compilation here is when a high-level language is compiled to another high-level language, which could be fed back as input to another process, usually to a language native to the platform that can then go through the native build chain. Runtimes here include things external to the platform that implement portions of an execution model needed to execute the app, like virtual machines, interpreters, and necessary libraries. The output category determines the type of app generated. Native code is the low-level code executed natively by the platform, and native code generates native apps. A native container bridges web technologies with platform-specific technologies by running web code in WebView on the native platform. A native container plus WebViews generates hybrid apps. As mentioned before, a native language needs to be processed again to become a mobile app. But it could also create a web app if the output language is JavaScript or WebAssembly. Once I put this together, I searched through documentation looking for how different tools worked and fit them into this model. I'm going to talk specifically about Ionic because it is a hybrid solution, but more importantly, I'll talk about React Native, Xamarin, and Flutter because they are so popular. And of course, I'll talk about Kotlin Multiplatform because that's why we're all here. One last thing before we move on. Notice how this starts to explain some of the negative feelings we have about cross-platform solutions. For any solution, we need to code in a new language. It will slow developers down. And if there's an interpreter or a VM between code being asked to run and code being executed, it's going to slow the app down. For hybrid solutions, a web view is fairly heavyweight and will slow things down even more. Ionic is a popular hybrid app development tool built on Apache Cordova. You write your app in standard web technologies. The runtime includes widget libraries and native platform interop libraries. Then everything's wrapped in a native container and you get a hybrid app. Now, the web and mobile are different. On mobile, you need to handle things like the offline experience, the application lifecycle, and back button expectations. Hybrid solutions promise to make things easy, but you actually need to work really hard to make a hybrid app meet native expectations. React Native takes something that worked really well on mobile, that is React, and makes it work really well on the web, that's React.js, and makes it work on mobile better than hybrid apps. You develop mainly in JavaScript, and the runtime provides native or native-like widgets along with tighter interop with the underlying platform. Native code is output at runtime by the JavaScript core interpreter, which allows the app to be categorized as native. The differences between web and mobile are still issues to consider, and it's easier to meet native expectations with React Native, but it is still difficult. For example, one of the problems mentioned by both Airbnb and Udacity is the three-platform issue. To make React Native apps more native, they had to deal with the JavaScript bridge and code independently for Android and iOS. This was more of a pain point than expected, and they needed to do it more often than expected. Xamarin was one of the first to focus on sharing business logic with native code across platforms. It was quite a bit later in Xamarin's life that they introduced Xamarin Forms to share UI as well. You write your code in C#, it gets processed to include the .NET runtimes. On iOS, it's all compiled ahead of time because iOS doesn't allow third-party execution engines. On Android, the Mono VM is included in the distribution, so it can just-in-time compile native code at runtime. Ahead of time compilation generally results in a faster app than just-in-time, and the benchmarks do show that Xamarin Android is significantly slower than Xamarin iOS. The Flutter solution is yet more native because it ahead of time compiles on both Android and iOS. You write your app in the Dart language, and for dev builds, the Dart VM will just-in-time compile. But for production builds, it will ahead of time compile all the necessary runtime libraries for widget rendering and business logic directly into native code. Kotlin Multiplatform is the most native solution yet. It is first class for developing Android apps. Kotlin is already the best for this and fully supported by Google. Flutter is not first class for developing Android apps until Google puts a lot more money into it and commits to it, because they will need to sustain both the material widget library on Flutter and the standard Android widget library. Neither Xamarin nor React Native will ever be first class for developing Android apps. Kotlin Multiplatform ahead of time compiles on iOS to a standard Objective-C framework, which is already first class on iOS. And even though Swift is becoming more popular, Objective-C frameworks are still prevalent. React Native is difficult to use in existing apps. Xamarin is impossible to use with natively developed apps, and Flutter is working on it. That's a huge difference. Kotlin Multiplatform is about optionally sharing and easily sharing code. React Native, Xamarin, and Flutter are foreign ecosystems with a disconcerting amount of vendor locking. Kotlin Native also outputs to JavaScript or WebAssembly for sharing code with the web. It is more difficult than it should be to share React for web and React Native, but there is a way. Xamarin isn't officially supporting web output yet, but people are trying. So Kotlin Native is ahead of the game, or Kotlin Multiplatform is ahead of the game here. This model is quite good, and this is how most people approach the definition of native, even if they haven't thought about it as deeply as this. Often it's simplified to just the app types, with web being on one end of the spectrum and native being on the other, with hybrid filling out in between. This is how Basecamp thinks about it too. I borrowed this image directly from a really good series of blog posts they have explaining how they architect their hybrid app to be more on the native side. But as we've seen, this picture hides some important technology details. Next up, I'm going to talk about a model that learns from the previous model that I just showed and helps us understand the difference between web, hybrid, and native apps on this spectrum. Then I'll present the model that unifies the developer experience, the user experience, and the implementation details. So this is what happened before Xamarin brought back the native multi-platform trend. Part of why I referred to the era after Xamarin as the modern era is because the solutions before it have either changed significantly or are mostly out of favor. And I'll illustrate that now. XLT86 and Algol 68C aren't in use anymore, at least that I know of. Later on, HTML, CSS, and JavaScript improved and could be considered part of the responsive web now. You can still find Flash, Air, and Appcelerator sometimes, but they are out of favor these days. And finally, we can consider Node.js and Java as runtimes on which cross-platform stuff is built. So I'll remove them too. Now we're ready to start building it back up again. At this point, it looks like responsive web and Cordova are the only way to make multi-platform apps. Let's add iPhone and Android to orient us in the native land. Wait, what's Android doing in the VM interpreter land? That's because Android got its start running a VM called Dalvik, so early native Android was not actually quite native. In 2014, Google announced Art, the Android runtime, which compiles apps ahead of time to native code. So traditional Android app development is native now. And let's not forget that C++ has been an option for a long time, and even the likes of Dropbox and Slack share code on mobile with C++ libraries. Cleaning this up a bit, just moving the colors around a little for what's coming up next. So I'm going to show you how the more modern solutions fit into this model next. I'm going to repeat some of the details from the previous model for Xamarin, React Native, and Flutter first. And then in the interest of time and popularity, I'll be brief about the others after. In the end of this section, I'll talk about Kotlin Multiplatform. Xamarin is native on iOS because it ahead of time compiles the C# there. It is less native on Android because the C# is just in time compiled via the included mono VM. One of the big issues with Xamarin on both platforms is you can't call a Xamarin library from traditional app. So choosing Xamarin is an all or nothing big decision. Adding in React Native, it runs in the JavaScript core interpreter on both platforms. The iOS platform provides JavaScript core, but it has to be included on Android in the APK, which could be a different version and the source of annoying bugs. Also, the bridging between JavaScript and native code I mentioned earlier is a source of annoyance. Flutter is native on both platforms because the Dart VM ahead of time compiles Dart on both of the platforms. It has a way to interop with native code via channels, which is better than the React Native bridge, but not as nice as Kotlin Multiplatform's expect actual mechanism. Now the others before getting into Kotlin Multiplatform. I mentioned TouchLab's work with J2OBJC earlier. It is native because it transpiles to native languages. RoboVM was a native solution, but it got bought by Xamarin and then killed by Microsoft. PWAs, or progressive web apps, usher in platform-supported hybrid apps, while WebAssembly ushers in native code for the web. And that is super interesting. Uber's ribs are native because they generate architecture boilerplate for Java, Kotlin, and Swift, which you can then use as part of traditional app development. So what we see here happening is we're learning how to build multi-platform solutions that bring the best of cross-platform and the best of native together in these modern multi-platform solutions. Kotlin Multiplatform brings them closer than ever. With Kotlin Multiplatform, Android apps are built as usual, so fully native and no added risk. On iOS, it outputs an Objective-C framework for native integration. And this is slightly annoying because we like Swift more, but it is still very normal for current iOS development. And on the web, it can output JavaScript and WebAssembly. WebAssembly has the potential to significantly change web development, and Kotlin Multiplatform is to be a first-class part of that change. So now we're ready to see the more complex model that unifies the developer experience, the user experience, and the implementation details of the different solutions. Early in 2018, I discovered the Stellar report. That said, this diagram from the Stellar report, you don't need to read, but it really resonated with me. And I was inspired to further analyze multi-platform solutions with this model. It shows at the top that we all have an image of the system in our mind, but the things we interact with are only a window into that system. The green line of representation in the middle is the boundary of what we see happening above the line and what is really happening below the line. It also reminds us at the bottom right, which you can't make out, but I'm describing it, that users also have a perspective into the system. Don't forget your users. So there's the maker's perspective, which is colored by the tools we use. There's the user's perspective, which is colored by the apps that we build, and all the stuff we can't see happening on the machines. In terms of multi-platform app development, there are the developers developing, designers designing, etc. There's the tools everyone uses, some first party to the platform, some not. There's the platform-specific services and implementations. And last but not least, the users of the platform. In this holistic model, we have to ask some new questions for each multi-platform solution. Is it native to the developer experience? Is it native to the platform, taking full advantage of what the platform provides? And do the apps generated meet user expectations? So here's that last model. Native to the developer means you are using the tools that the platform provides, Android Studio and Kotlin, Xcode and Swift. Native to the platform means the app's implementation is not abstracted away from the machine. Native to the user means the app matches the user's expectations of the platform. Now, it is possible to build a bad app whether you use the tools that come with the platform or not. But if you can use the platform provided tools and widgets, there will be less risk and effort to meet those expectations. So for the purposes of this model, if a solution puts itself between the tools it provides and the platform provided tools, it is not going to be in this category. As with the previous model, I will go into some detail for Xamarin, React Native, and Flutter first, be more brief with the others, and then emphasize Kotlin Multiplatform at the end. To start with some stakes in the ground, traditional Android and iOS development are fully native by definition. Responsive web and Cordova aren't native to the mobile developer, the mobile user, or the mobile platform, so I won't be talking about them anymore. Xamarin is native to the platform on iOS, but less so on Android because of the mono VM. It is not native to the mobile user because it requires use of custom widgets, or if you want native widgets, Xamarin Android gets in the way. It's also not native to the mobile developer because you have to use Visual Studio and C#. React Native is partially native to each platform because it runs in JavaScript core on both platforms. It is not native to the mobile user because it requires the use of custom widgets or native widgets with bridging gymnastics. And it is not native to the mobile developer because you have to use non-standard IDEs and JavaScript. Flutter is native to both Android and iOS platforms because it is ahead of time compiled to machine code on both. But it is not native to the mobile user because although Flutter team is creating Material and Cupertino widget libraries, they are not native to either platform. They'll probably keep up on Android, but it is still a level of indirection that is likely going to bring your apps into an uncanny valley. And while it is more native to the Android developer because you can use Android Studio, it is not to iOS developers because you can't use Xcode. And for all developers, you need to use Dart. Those are the big ones people like to talk about. And here are some others quickly. J2OBJC simply transpiles Java to Objective-C, so the output is native everywhere. Uber's ribs are similar in that they just auto-generate boilerplate, so that they are native everywhere too. RoboVM did let you use Android Studio and Xcode before it was killed. And where the web is encroaching on native development, progressive web apps make web more native in functionality, and WebAssembly is making web more native in implementation. But both still aren't native to mobile developers or users. Now to emphasize Kotlin Multiplatform, the most native solution yet. From an Android perspective, Kotlin is already the best language for native Android app development, and Kotlin Multiplatform doesn't get in your way. From the web perspective, Kotlin Multiplatform outputs to JavaScript and WebAssembly. And when WebAssembly is mainstream, web development will significantly change and Kotlin Multiplatform will be first class. Until then, Kotlin will take some getting used to by JavaScript devs. For the iOS perspective, Kotlin Multiplatform is slightly foreign to iOS developers right now, but it generally fits into the native iOS development experience. Kotlin and Swift are very similar syntactically, and for UI and the parts of your code you aren't sharing yet, you can still use Xcode with Objective-C or Swift. Since Kotlin Multiplatform lets you use the native tools for UI, you can create the best native experience for users. On the platform side, it provides native performance because it compiles to native code, and it interrupts directly with the native runtime, so it won't lag behind platform innovations. In the future, it's actually getting better for iOS developers. TouchLab isn't the only company with interest in Kotlin Multiplatform. Square, Google, JetBrains, of course, and others also have an interest in improving the iOS developer experience by improving integration with Xcode, like an interactive Kotlin debugger with Xcode, improving Swift interop, like generic support and transparent mapping between data classes, and also creating more libraries. So Kotlin Multiplatform is the most native solution from all perspectives. It's also the least risky multi-platform solution. You can deploy bug fixes faster because you can fix the bug in shared code and all platforms get the fix, and you decrease the chance of platform-specific bugs in the first place. You can deploy new features and enhancements faster because you can share business logic without diverging implementation. Developer efficiency in general is increased because of the above, but also because more of your testing, refactoring, code review, and other efforts for each platform are in one place. And last, for this discussion, but not an exhaustive list, you can reach a wider audience by deploying features on both platforms with little delay. And if you want to deploy one platform first, because people with more money are on iOS and more people are on Android, there's no longer a technology constrained decision. This is a business strategy decision now, as it should be. While Kotlin Multiplatform is not perfect, and let's be completely honest, if you are an early adopter if you start now. It does significantly improve upon some of the things historically risky in multi-platform solutions, and it continues to get better. It provides native performance, not lower performance, because it is ahead of time compiled to native code. It allows you to keep up with platform-specific innovations because of native interop on all platforms. You can spend high-value time and effort developing the best user experience possible because you can use native UI tools, libraries, and widgets. It's also future-proof because while platform capabilities and official design guidelines keep innovating, you are not held back. Android Studio and Xcode are officially supported by Google and Apple already. Kotlin and iOS frameworks are officially supported by Google and Apple already. And let's not forget web. JavaScript isn't going away, and WebAssembly is maturing. Kotlin Multiplatform supports both. All right, so thank you for following along. I hope this helps you understand the multi-platform solution space a bit better, how Kotlin Multiplatform fits into it, and why we at TouchLab are excited to be on the front lines. Now let's answer as many questions as we can with the time remaining. Yep. All right, so first, will the slides and recording be available? Yes, they will.
Are we sure we're recording?
We are recording. And next one, I will hand off to Kevin. It takes two to tango with Kotlin Multiplatform. How do you expect iOS developers to contribute and not lose momentum with Kotlin Multiplatform?
So let me try to piece apart that question, right? I guess it depends on how we look at this. So obviously, it would be disingenuous to say this isn't going to be perceived as an Android-focused solution to shared code, right? So Kotlin is native on the Android side 100%. And when I say native, there's different definitions of native that Justin went through. There's like, CPU instruction set native, like the very literal interpretation of native. I just mean like it's native to the developer on the Android side, right? On the iOS side, they're syntactically similar, Swift and Kotlin, but they are definitely different things. We are, as a team, currently, a lot of our open source work is focused on making this a more native, quote unquote, experience to the iOS developer. So we're trying to improve the development experience for the iOS side. It was mentioned somewhere in there, and we haven't publicly announced it, but somewhere next week, I think we will. We developed an Xcode plugin that lets you dynamically debug Kotlin source code from compiled code. We are actively working with JetBrains, and I'm going to submit a pull request sometime in the next few days that gets significantly better generic support, so it's more fluent on the Swift side. Things like that, and that's going to be something that is the large focus of our efforts to make this a more iOS friendly situation. We don't we don't want this to, it's going to be harder to sell if to the iOS teams it feels like something that is being handed to them, sort of a stepchild hand-me-down situation. So we're making that better. Fundamentally, if an iOS developer wants to edit Kotlin, you have to understand Kotlin, but it also allows the iOS teams to be pushing code to the Android side. So how do they not get behind? There's functional considerations, and these are true of any sort of shared code thing. There's a great Slack or a Medium article from Slack about using C++. And, there's some fundamental rules that you shouldn't break. Like, you shouldn't deliver compiled libraries and not let the other teams edit. They have to be able to edit the code, to debug it, to test it, to do fixes. Otherwise, you wind up in this horrible, sprint cycle where, everything takes forever. There's functional ways to do that, and that's a much longer discussion. But yeah, I don't know. Well, Xcode, I would say, could be available today. But we're putting together sort of an announcement and some blog posts. So that's a good question. Sometime in the next several days, if you absolutely want to try out the Xcode plugin, just reach out. We'll give you access today. It's not a problem. Generics is more of a negotiation with the JetBrains developers. So that's an interesting story. There's a long, if you want to know, I can forward it to you. There's a public chat on the Slack channel that I'm in about when is there going to be direct Swift and drop? What does that mean for generics? Can we add generics to Objective-C? Yada, yada, yada. I'm actually submitting sort of a proof of concept pull request. I'm going to try to get this in for Kotlin 1.3.3 the next few weeks. I doubt it'll be in, but you'll be able to test it out yourself if that's what you want to do.
Please continue sending your questions. These are great. For Sam, any advice on selling this internally? Sam is our lead engineering manager here, and he needs to sell this stuff to our devs.
Sure. So Kevin covered a lot of sort of the people side of selling it to iOS developers. One key thing we also have been striving to do is sort of a culture change to really look at all of us as mobile developers and step away from the Android developer, iOS developer little niches. And so, leveraging these similarities of Kotlin and Swift and recognizing that, we're all mobile developers at heart, I think has helped us all kind of approach it from a better place.
Can I go on? I was going to sort of pile on top of that. One of the things, and this is my discussion of risk, and it's less around hardcore technical risk than it is around de-risking the future. So I can't tell you whether or not Flutter is going to be like all of mobile. I doubt it. But I can't tell you for sure. I can't tell you that the web isn't going to push native out almost entirely in the next 5 years. I doubt it, but I don't know. I can tell you that everything from now on is mobile, at least architecturally. And if you don't think that way, then you're going to have a difficult time. So a lot of times, web developers will come to mobile and, maybe for React Native, get excited that they can just take their web techniques and make them mobile. But being mobile doesn't mean just using, being on a phone. There's offline, there's network considerations, obviously screen size, all kinds of stuff. So I don't know, maybe WebAssembly and web components and HTML rendering will become how you deliver most of your things on the phone in the future. I don't know, but I do know that everything's mobile. Having a shared architectural viewpoint, this is kind of how we're coming at the Kotlin thing. It de-risks if you've got a team that is very fluent in how to build this kind of stuff, regardless of how the industry sort of shifts in the next few years. You're not going to be in this, oh no, we have to retrain everybody and start from scratch and rewrite our whole apps, that kind of thing. That's the point of the risk, at least organizationally from my perspective. So being mobile developers first and not platform-specific developers is part of that change.
Yeah, I think selling it internally to stakeholders or kind of your principal developers and stuff as well, you're also able to approach it from a very limited, small cross section of your app. You can have optional business logic converted over while you get people adapted, and really sort of improve the architecture of your app in the process.
Yeah, so to jump on that, not to, I've been speaking to iOS groups. I actually spoke at an iOS meetup, and we can't talk about a client that we have right now that hopefully in the future we will be able to, where our whole job is essentially to help their iOS teams get on board with this. But starting in a place that's always painful is a good place to start. So for example, I haven't met a lot of iOS developers who are super excited about core data, and storing things in SQLite is something a lot of apps need to do. We've been heavily involved with the Square team in producing SQLite, which is a cross-platform SQLite layer, including we wrote the driver for that. And going into a team and saying, look, we can make that part a whole lot more fluent and easy to deal with and not duplicate code is a good place to start. And because, again, Kotlin is an optionally sharing, embraces the nativeness of the platform, it doesn't, you don't have to jump through a lot of hoops to have that. You essentially just create a framework, import it to Xcode, and you can call it from Swift, and treat it just like any other framework that's part of your build. So that's like the really critical, one of the big critical differences of this kind of code sharing. So.
Segueing into the next question, this is a perfect one for Kevin because he loves Flutter so much. Sharing language is one thing, but doesn't Kotlin require you to still use the given native frameworks to lay out UI where Flutter solves this problem?
So I try to preface every time I talk about Flutter with I'm not anti-Flutter. I think Flutter technically is really interesting. But, the Flutter is not the first shared mono UI system to be deployed in computing, right? My career, essentially my professional career, started around Java 1.0, and you get to watch the whole, we're going to write once, run anywhere history emerge. And it's not necessarily pretty and not necessarily something that works out well with shared UI. So you could have built your apps in Adobe Air. You can build them, using web as your UI layer. You can do that to some degree with React Native, etc. There's other options for shared UI. Why is Flutter fundamentally different than these other things? I just had a long Twitter thing about why I don't really think Flutter was intended primarily as a multi-platform vehicle so much as a portable UI, and is going to largely find a home if and when Fuchsia ever deploys, right? If it was really going to be a multi-platform solution, why is it Dart and not JavaScript? There are endless reasons why that would have made more sense. But getting back to Flutter solving the problem, Flutter solves that problem if you're okay with the UI that it presents, and you're okay with the constraints that are going to come along with it, and you're okay with the risks that might be involved, such as if you have two existing teams, now these teams need to learn an entirely separate language, deal with an ecosystem that is not super flushed out, deal with perhaps Apple's future unpleasant reaction to what happens from this. Maybe if Google runs out of reasons to support iOS in the future, are they going to continue to fund DevRel and development to maintain the platform? Google started pitching us on Flutter for production client apps in the middle of 2016, right? And I asked them then, how many large production Google apps are you going to publish with Flutter? And they didn't have any then. They don't have any now. So again, it all comes down to risk. I think if you're doing a proof of concept, a couple of small individual developers, maybe you're a startup, it's something you can look at. I'm not going to say it's necessarily cheaper, but I don't know. If you're going to build something that has to last for the next 5 to 10 years, indeterminate, if you're going to have to restaff or retrain, who knows? I don't know. I find it to be something of a risky nature. Kotlin Multiplatform is new. There isn't a good UI story yet. I'm expecting something that's similar to what's happened in the React Native world, where they have a common UI definition that can be rendered in the native UIs on the individual platforms. But again, of critical importance is I'm sure you will be able to just integrate natively where you see fit and use shared definitions where they're valuable, right? So 80% of your app is only touched once, if ever, right? Like setting screens, all that kind of stuff. They don't need to be super, super UX perfect. Your main screen interactions do. Where Flutter is kind of risky, now you can, let's say up until the last couple of months, you couldn't even integrate any HTML content. And now you can technically, but it's really weird. Like they create an invisible OpenGL window and underneath it, they'll render some web and then shuttle clicks back and forth. And hopefully that works out. It's just Flutter definitely treats the native platform as a quarantined, hands-off thing, and integrating native stuff is tough. And it's not just the screens that are native. It's notifications, it's whatever. So I don't know. We look at it as risky. Other people disagree. See how it goes.
Right. We are coming to the end. So there's one last question that we'll talk about. Does Kotlin support iOS storyboards for UI development? As I mentioned in my slides, yes, it does. There is, right now, as Kevin mentioned, there's no shared UI development in Kotlin Multiplatform now.
Oh, sorry. Yeah, go on. I mean, it's sort of like, it depends. Like there are people that are taking stabs at it.
Working on it.
I would expect in the next 6 months to a year that someone's going to have a serious entry. I've seen a few not super serious ones.
But that is one of the reasons why we like Kotlin Multiplatform, is because it focuses on the business logic, and it allows you to use Android Studio for your UIs, and allows you to use Xcode storyboards for your UIs. I think that's what we do in the DroidCon app.
We use storyboards for the UIs. I mean, this also gets into like large team dynamics where people who are in larger teams are sort of anti-storyboard, which is another thing. But yeah, you can do that. You can actually use a storyboard and then have your UI code implemented in Kotlin. I would not recommend it. That's what Swift is really, going to be great for. It's don't make life more difficult than it needs to be, honestly.
All right, cool. We will go through the rest of the questions and answer them to you individually. And maybe some of them may turn into blog posts as well, because we love talking about this stuff. Before we sign off, you have some homework to do. Watch some related conference talks. That is people on the top talk that you may know about, talking about SQL Delight being a multi-platform delight. And at the bottom, we have our very own Kevin Galligan talking about architecture on mobile. Also, clone the many related open source projects that are out there. They continue to grow. We want to work with the community, and we want the community to grow. So we are fully part of the open source community here. Kotlin also has its own community, so don't hesitate to get involved and ask for support from the official channels, the Kotlin Slack, and directly to us, of course. Talk to TouchLab, because we can support you with staying up to date with, we can consult you on, and we can consult you on the implementation. We can build the implementation for you on all this stuff. So thank you for joining, and hope to talk to you soon.